ladies, I just thought I'd quickly do a proposal for you. I like the title, The Intermediate Principles of Quantum Computing. I think that's good. It's a sort of like a foundation for them. Okay, so I've got 12 sections, 12 lectures, and I know we've spoken about the fact that these people will know, the basics of quantum physics like entanglement and superposition, but I do think it's very important to go through it, and I'd like to dedicate a lecture to it. If for no other reason, then we're trying to set these people up as quantum experts, and I think you need to understand the real mysteries of quantum physics, like, for example, the delayed choice quantum eraser, which I would say 99% of people in the quantum computing industry are totally unaware of it, yet it is amazing. It shows how the observation doesn't have to be real to collapse the qubit. I'm explaining that rather quickly. It also shows how events that have already occurred can be altered. So again, it just gets over the wonder, the mysteries of quantum physics, because all quantum computing is doing is exploiting these mysteries. So you need to know what they are. And it's a very interesting lecture. After this, I'd like to talk about the next lecture will be the various interpretations of quantum mechanics. Anybody in the quantum world should know these. They should know the Copenhagen and certainly the many worlds interpretation by Hugh Everett. These things are important. Okay, now we start getting into the quantum computer side of things, and you need to know your basics for linear algebra. So here I just take a lecture out. I know some of these people will have done linear algebra before, but it's worth going over, especially the points that are relevant to quantum computing. Now we're getting into quantum computing. So a good lecture on the Bloch sphere, talking about quantum states and how they're represented on the Bloch sphere, and certainly the measurement bases. That's very important. And that's a whole lecture in itself. Then traversing the Bloch sphere, which of course is just explaining that everything can be explained by matrices. So you multiply one matrix by the other, and you're changing your coordinates of the quantum state, and that's what it's all about, basically. I also mentioned in here, as you can see, quantum tomography, which is, I always say to people, we can't measure the result. And so everybody says, well, if you can't measure the result, how can we ever get to the result? And of course, the answer is through quantum tomography, by doing the same process to the same quantum states literally millions of times. So there's that. Then going over quantum gates and algorithms, just basic, of course. And then a deep dive into quantum algorithms. I think it's so important to talk about Deutsch's oracle and the Bernstein-Vazirani algorithm, because these two show the advantages that we get through quantum processing. And then I'll just mention in discussion Shaw's and Grover's. And then an introduction to Qiskit and a tour of the IBM Q experience. Qiskit's not my strong point. You guys, I am sure, know more about Qiskit than I do. But this isn't a deep dive into Qiskit. It's just the very basics, which of course they should be familiar with. Then I talk about my favorite quantum teleportation, Quantum teleportation is going to be at the heart of almost every quantum scenario in the future. So it's very important to understand it, and again it teaches some great principles of quantum computing. Then talk about quantum cryptography, which is one of the main reasons why quantum computing is going to make such a difference to society. Then the quantum cloud, the quantum internet, which is already beginning to be operated in the University of Delft. And then I talk about the various types of technologies, because again, an expert in quantum computing needs to know these. So that's it. I hope this has given you a bit of a insight to where I'm coming from. Please make any comments. These are just ideas at the moment, and I'm happy to change them depending on what you want. Thanks, ladies.